Welcome back, folks. In the last video, we converted polar coordinates to rectangular. This video picks up where that lesson left off, and we're going to talk about converting rectangular coordinates to polar. So I'm going to shoot all the way down to the bottom of the last page where we left off, and I'm going to kind of pick up here. So where it says convert rectangular, it means convert points in the xy plane or the xy axes to their corresponding points that are in polar. In other words, in the form r comma theta. All right, this video too, I'm going to kind of try to keep moving in the interest of keeping it brief, but if you need to, just a reminder that you can always stop me, rewind me, replay me, but please, whatever you do, don't mute me. All right, let's go ahead, let's get started. Number 2 says convert a point -5, -5 to polar. My approach for this is going to be just like my approach was when I was converting in the other direction. I'm going to start by going ahead and plotting that point. So -5, -5 is going to put us in quadrant 3. Where I've moved 5 units to the left of the origin and then 5 units down. I'm then going to take a look at my special right triangle that's formed. In this case, it's going to be the 45, 45, 90 right triangle. And remember, the side length relationship in that right triangle is 1 to 1 to root 2, making that hypotenuse there 5 root 2. And for our intents and purposes, our hypotenuses are always going to be positive. Oh, and there was something else I was going to say about that as well. Can't remember what it is, so I guess it's not that important. So remember that to name our point in polar, we have to name both a radius and an angle. Well, the radius length is always the same as the hypotenuse, so our radius length here is 5 root 2. And our angle measure, remember we always start on that positive x-axis, and we want to go to the quadrant 3 angle whose reference angle is pi over 4. So remember, pi right here is really 4 pi over 4 plus another 1 pi over 4 makes that angle 5 pi over 4. Now remember, we are now back in the land of polar. There are 4 different possible ways to name each polar point. So as long as you come up with one of those 4, you are indeed correct. My advice to you is going to be to watch out for domain restrictions because they might tell you that the angle needs to be between 0 and 2 pi. They might tell you that the radius has to be positive. So just be careful and make sure you read and follow directions with the way they want that answer expressed. But if it's not otherwise stated, you can name that polar point in any way of your choosing. All right, that was fun. Let's try another one. Letter B says the rectangular coordinate 0, -2. So 0, -2 is going to be right there. So if I'm looking at here, my radius length or my distance from that pole is going to be 2. My angle is going to be 3 pi over 2, making that point 2, comma, 3 pi over 2. And again, there are 4 different ways to name that polar point. You only have to find one. All right, love those that end up on an axis. Letter C says 1, comma, -root 3. So that's going to put us in quadrant 4. So 1, -root 3 is going to be 1 unit to the right of the origin, root 3 units down from the x-axis. 1 to root 3 to 2 puts us in the 30, 60, 90 right triangle. My smaller angle is opposite the 1. My larger angle opposite the root 3. So as far as polar coordinates, remember that the hypotenuse of your triangle is the same as your radius. So radius here, length 2. Angle measure here is going to be 5 pi over 6. And again, that's one possible way to name that angle. Oh, not 5 pi over 6. Let me go back. My reference angle is pi over 3. So I like 5 pi over 3. But I could have called it 2 negative pi over 3. That would have worked equally as nice. You just have to find one possible angle measure. All right, up at the top of the next page, letter D, negative 3 comma 3. So he's going to be in quadrant 2. And he'll be 3 units to the left of the origin, 3 units up. Looks to me like I'm living in the isosceles right triangle, or the 45, 45, 90 right triangle, where that ratio is 1 to 1 to root 2. Since my legs have lengths of 3, hypotenuse is going to be 3 root 2. So as far as naming this in polar, remember again that radius is always the same as the hypotenuse of your triangle. So 3 root 2 for the length of the radius. And then the angle measure, that reference angle is going to be pi over 4. So if I'm living in quadrant 2, angle measure is going to be 3 pi over 4. And again, there are 3 other ways to name that. Just pay attention to domain restrictions if you're working in Delta Math. Letter E says 1/2 comma negative root 3 over 2. So this is going to put me in quadrant 4. I'm moving 1/2 unit to the right of the origin, root 3 over 2 units down. So I'm seeing those 1s and 2s and root 3s in there, and I'm thinking 30, 60, 90 right triangle. So root 3 over 2 is larger than 1/2, which is going to make this my pi over 6 and this my pi over 3. Hypotenuse is going to be double the length of that shorter side. So if I double the length of 1/2, doubling the length of 1/2 gives me 1 for the length of my hypotenuse. So as far as naming the coordinates of that point, radius length, always the same as the hypotenuse of your triangle, so 1. Angle measure here, if you're going in a counterclockwise direction, can be 5 pi over 3. If you're going clockwise, can be negative pi over 3. Either one of those is going to be a suitable answer and get you full credit. Just again, if you're working in Delta Math, be careful, pay attention to the domain. All right, letter F says 0, negative 4. I'm loving this one right off the bat because I end up right on one of those axes. So my length, 4 units away from the origin. My angle measure here going to be 3 pi over 2. But again, I could also call that 4 comma negative pi over 2. That would work just as nicely. Any one of those 4 different coordinates is going to be enough to get the job done. All right, moving forward, letter G, negative 5 root 2, negative 5 root 2. So both coordinates are negative. That's going to put me in quadrant 3. So I'm looking at that isosceles right triangle, whose ratio is 1 to 1 to root 2. So we know the length of the leg is negative 5 root 2. To find the length of the hypotenuse, we have to multiply that leg times root 2. So I'm going to do negative 5 root 2 times root 2, which is going to be either negative 5 root 4 or negative 5 times 2 or negative 10. My hypotenuse, though, remember, is always going to be a positive number. So I'm just going to make its length 10. So now to name my coordinate in polar, I've got a radius of length 10, an angle measure of 4 pi over 4 plus pi over 4, or 5 pi over 4, or any one of the 3 other equivalent points. All right, letter H is a calculator question, so how about we skip it? Letter I is a calculator question, so how about we skip it? I'm liking the same for letters K and L. Wow, those were easy. Making letter J our last question. All right, negative 7 comma 0. So negative 7 comma 0 is going to lie here on the negative x-axis. And again, if I'm thinking about converting to polar, the length of that segment there is 7, making the radius 7, and the angle measure pi, or one of its other 3 equivalent points. All right, down in the box where it says calculator steps for polar conversions, we're not doing that. I'm just going to put an X to remind myself if I look back in my notes that don't need to know that, not important for what we do. We're only going to convert this year using our special right triangles. All right, folks, as always, thank you, thank you, thank you for the gift of your time and your attention. Until we meet again, I will miss you. Take care.